This video is on the sine rule. So here's the triangle ABC with the vertices labelled A, B and C, so that's why it's called that. The same labelling that we did with the cosine rule in the last video. Let's call the sides opposite these vertices the lowercase of that letter. So this side we're going to call little a because it's opposite the vertex big A. This side we're going to call little b because it's opposite the vertex B, and this side we're going to call little c. And let's call the actual angles A, B and C depending on what vertex they're at. So this angle here we're going to call big A because it's at the vertex A. This angle we're going to call B, and this angle we're going to call C. The sine rule is that the length of side A over sin of A is equal to the length of side B over sin B, which is equal to the length of side C over sin C. This isn't given to you in the formula booklet, so you'll need to learn it. Now, normally you won't use all three of these, you'll usually only use two of them. And the good thing about the sine rule, similar to the cosine rule, is that let's just take these two for example, and the things that you need to know are A, B, and then A, and then B. If you know three of these, let's say you know A, B, and B, therefore you can figure out A from that. That's what's useful about the sine rule. And once again, like the cosine rule, the good thing about the sine rule is we can use it with any triangle, not just right-angled triangles. So what's really key to the sine rule is we need to know the values of a pair of a side and its opposite angle. So for example, we need to know the value of A and its opposite side A, and this is where the sine rule is really useful if you have this. So for example, let's say that we have an angle here of 30 and we know the length of the side opposite to it as 5. Well, what we can do, we have this pairing of an opposite side and its angle, and therefore we can fulfill one of the parts of this equation. So let's just do the A part here. It's going to be 5 over sin 30, which if you put that into a calculator is equal to 10. So that means we've completed one part of the equation, and that's really useful for the sine rule, because then we can do 10 is equal to, let's say, b over sin b, and let's say we know the value of little b, the length of the side, therefore we can then figure out angle b, and vice versa we can do that for the c value as well. So that's what's really useful about the sine rule when we have this angle and its opposite side value. And if you have this is usually an indicator, if you have this in the question, this opposite pair, that you should be using the sine rule in order to answer the question. So you can use the sine rule in two instances similar to that of the cosine rule. The first instance is when you need a side and you're given this side's opposite angle and the pairing that we talked about before, and another pair of a side and that side's opposite angle. Again, I can't emphasize it enough, this pair of a side and an opposite angle is vital for answering sine rule questions. So let's do an example of this. We have a triangle below and we have this opposite side and angle pairing. So that gives us a massive clue that we're going to use the sine rule. A over sine A or sin A is equal to B over sin B, which is equal to C over sin C. Now, you can use the letters if you want to. I usually don't use the letters. I just realised that, okay, this is an opposite side and this is an opposite angle. So these are going to be kind of in the same fraction, in the same fraction. So this is going to be 10 over sin 45. And this is equal to, we need to find x here, and we have the opposite angle. So it's the side over the angle. So it's going to be x divided by sin 30. If we put 10 over sin 45 into a calculator, it is equal to 10 root 2, and then sin 30 is equal to a half, and then x divided by a half is just 2x, and therefore we divide everything by 2 to just get 5 root 2 is equal to x, and that is the answer. The second instance in which you can use the sine rule is when you need an angle and you're given the angle's opposite sides, and again you're given this pair of a side and its opposite angle. Now, so far I've introduced you to the sine rule as a over sin a is equal to b over sin b is equal to c over sin c. And this is the way that you write the sine rule in order to find a side. But when you're trying to find an angle, there is an alternate way that the book gives the sine rule, is by basically just flipping everything and doing sine a over a is equal to sin b over b, which is equal to sin c over c. These two are the exact same thing, because if you think about it, you're just doing 1 divided by whatever is in the equation, and because you're applying, so for example for this first one over here, you're doing 1 divided by a over sin a, which obviously would just flip the fraction to sin a over a, and you're doing that for every single one of them, so therefore it's equivalent because you're affecting every single one of them the same. So this is a valid way to write the sine rule, and I actually agree. I think this is actually a lot easier in order to do sine rule questions when you need to find an angle, this version, because in this version the angle is in the numerator, and when you actually go into rearranging, it's slightly easier when the angle is at the top. You can still do it using the other formula, but this makes it noticeably easier in some cases to use the other one. And the way to remember this is what you'll actually find is that whatever you're trying to find, this will be the one at the top of the fraction. Here we're trying to find the angle, so the angle is on the top of the fraction. On the other one we're trying to find the side, and the side was on top of the fraction. So here's an example where we need to find an angle, and because we need to find an angle, I'm going to use the alternate version where the angle is on the top. So it's sin a over a is equal to sin b over b, which is equal to sin c over c. We have this opposite angle and side pairing, which gives the indication that we're going to use the sine rule. Again, I'm not going to use the letter label, I'm just going to realize that this is an opposite side and angle pairing, but we're going to put the angle on top this time. So it's going to be sin 85 over 16 is equal to, and we have the opposite pairing here of the theta and the 13, to get sin theta over 13. Times both sides by 13 to get 13 sin 85 divided by 16 is equal to sin theta. If you put this into a calculator, this is equal to 0.8094, and this is equal to sin theta. Now, by the way, because it asks the 2 decimal places isn't that important, I usually do it to 2 more, my kind of working in between, to 2 more decimal places, and it's required to make sure actually, so I don't have 4 decimal places here. That's not that important though. And therefore, theta is equal to the inverse of 0.8094, which if you put into a calculator is equal to 54.04. So theta is equal to 54.04. So overall, these are the 2 scenarios in which you can use the sine rule. The key 2 things to take away is when you see this pair of a side and its opposite angle, that is a massive clue that you're going to need to use the sine rule in order to answer the question. And the other key thing to take away is when to use 2 different versions of the sine rule. I think this tip in the light blue is really good, of whatever you need to find is on the top of the fraction. So in this scenario, you need to find a side, so therefore it's the side that is on top of the fraction. Now, there is a special case of the sine rule that you need to be aware of that can occur in some instances when you're finding an angle and they give you the pair of an opposite side and angle and the side opposite to that angle that you're trying to find. Here is a question like that, and note the important thing is they haven't given us a diagram, so we're going to have to just draw one ourselves quickly. So let's quickly do that. I'll do a line here, then I'll connect this by a line like this. And then I'll draw, so I can't use a ruler like this because I can't use a ruler on a drawing tablet. So I'll draw lines like this, call this A, this B, and this C. So AB is equal to 10, BC is equal to 8, and angle BAC, which is this angle here, is equal to 32 degrees. And we need to find BCA, which is this angle here, which is theta. So let's just do this. So what it's going to be is, because we need to find an angle, it's going to be the sine A over A with the angle on top is equal to sine B over B is equal to sine C over C. Okay, so the opposite angle and pair here is 32. Opposite angle and side is 8 and 32. So it's going to be sine 32 over 8, and this is equal to, and then the opposite side of an angle here is 10 and theta, so this is going to be equal to sin or sine theta over 10, times both sides by 10 to get 10 sin 32 over 8 is equal to sin theta. Put 10 sin 32 over 8 into a calculator and you get out the value sin theta is equal to, you get out the value of 0.6623, and then in order to get theta, theta will be the inverse of 0.6623, which you put that into a calculator, is equal to 41.48. So theta is equal to 41.48. Now note that the question says to find two possible values of theta, and the reason for this is because there's actually two ways that we can draw this triangle. One like we did here, but another very similar triangle where we still have this line here and we have some of this line, but rather than drawing this line here, instead we draw it going down here. Connect these two lines and then we call this C. This triangle is also valid because the jurisdictions that they gave us in the question are still true for this triangle as well. AB is still equal to 10 as it's the exact same line. BC is also equal to 8 here. This line is also equal to 8. And angle BAC is also equal to 32 as we haven't changed it. And theta is now here. The only difference between these two triangles is the length of AC, but because there's nothing in the question that talks about the length of AC, this can change and this can vary. So both of these triangles are valid, and as we can see that this new angle of theta is actually obtuse, whereas this angle is actually acute. So both of these triangles are valid and both of these answers are valid, with one of them being obtuse and one of them being acute. So where does this value come from? Where does this obtuse value come from? Well, it all comes from this part here. Sin theta is equal to 0.6623. And the reason for this is because there is actually two values for where sin theta is equal to 0.6623. If we draw out a very quick sin graph, so this is the y-axis and this is the x-axis, and we draw it out like this, where this here is 0, this is 90, this is 180, this is 270, and this is 360. We'll talk more about drawing sin graphs in a few videos time. This is the sin graph. We won't consider anything beyond 360 degrees as theta can't possibly be that, as it's an angle. And if we say that 0.6623, let's say it's about here, 0.6623. Let's say it's about here. We can see that there are actually two values for where sin theta is equal to 0.6623. One here and one here. And one of them is acute, below 90 degrees, and one of them is obtuse, above 90 degrees. And this is where these two values come from. So how do we get this obtuse value? How do we get this obtuse value here? Well, the formula is 180 divided minus theta. This is the formula that they give you in the book. So it would be 180 minus theta, which we got before the acute value, which is 41.48, which if you put this into a calculator, is equal to 138.52. So that is the other obtuse value. Now, I hate remembering formulas, as I've said this before, so the way that I do this is rather than remembering the formula, in an exam I very quickly draw out a sin graph like this, and I think in my head, okay, we know the value of this point here, this is 41.48, so therefore the difference between this point and 0 is obviously going to be 41.48. And as a sin graph is symmetrical, the difference between 0 and this point is going to be the same as the distance between 180 and this point. It's going to be the exact same distance, 41.48. So therefore, this point is going to be 180 minus 41.48, which is equal to 138.52. You'll find if you put sin 138.52 into your calculator, it will indeed give out a value of, when you round it, to 0.6623. Now, I acknowledge we've basically done the same thing as the formula. The only difference is here we've remembered a formula, whereas down here we've figured out the formula in a few seconds logically. So again, I hate remembering formulas, but I do it this way. If you want to use the formula, that's completely fine. We'll talk more kind of about this technique in chapter 10. So all you need to note from this is that your calculator will only give you out the smallest angle of theta. Theta is equal to 41.48. But there will also be a bigger value of theta, which you'll have to figure out yourself, 138.52 in this instance. Now, for most questions, you won't need to do this, and the reason is because they will give you a diagram like this. For example, the grey bit, they will give you this diagram and they will show you that theta is acute, and therefore you don't need to worry about doing the whole obtuse thing, because you clearly know that it's acute. But if the question says anything about it being an obtuse angle, or if it's a question like this where it says there are multiple possible values of theta, that is a really good indication that you need to be thinking about this special circumstance.